Classification of signals. So the learning objectives are the students will be able to understand the types of continuous time signals and to identify whether the signals are energy or power for the given signals. Now see the classification of signals, continuous time signals and discrete time signals. Continuous time signals is defined at every instant of time t. The amplitude of the signals varies continuously with the time. So the example of continuous time signals are voltage and current, pressure, temperature, velocity. Discrete time signals, it is defined for the discrete instant of time. The amplitude of the signal varies at every discrete value n. So the examples of discrete time signals: DNA base sequence, population of the nth generation of certain species, pixels, daily stock price. Now see the classification of continuous time signals. So energy and power signal, periodic and aperiodic signal, even and odd signal, deterministic and random signal. So now see the what is energy signal. So the energy signals, the instantaneous power of the resistor is written 1 by R V square of T. The total energy expended over the interval is equal to integral T1 to T2 1 by R V square of T dt. The average energy signal is given by 1 by T2 minus T1 into integral of T1 to T2 1 by R V square of T dt. So this concept defined for any continuous or discrete time signal. So the energy signal is defined, the signal energy in the signal x of t is given by E is equal to integral minus infinity to infinity and the square modulus of x of t dt. So the signal is referred to as energy signal if and only if the total energy of the signal satisfies the condition 0 less than E less than infinity. The power signal is given by the P is equal to limit t tends to infinity 1 by 2t integral minus t to t and the square magnitude of x of t dt. So the signal is referred to as an power signal if and only if the average power of the signal satisfies the condition 0 to infinity. The square root of the average power is called as a root mean square. So now the two important classes of signals, the finite total energy and zero average power, the finite average power and the infinite total energy. So this is an example of energy and power signal. So let us consider the signal x of t is equal to e power minus t q of t. So the energy of the signal is equal to integral minus infinity square magnitude of x of t dt, and substitute the x of t and solving, so we get this, the E is 1 by 2. The signal x of t is an energy signal since the E is finite and the signal power P is equal to 0. And the second example, let us consider the compact signal x of t is equal to a e power j omega naught t. So the signal x of t is a periodic with a period t naught, so it cannot be an energy signal. And to compute the signal power, so we use power equation. The power is equal to a square. So the P is finite, the x of t is a power signal and its energy is infinite.